We live in exciting times. The world is changing faster than ever before. One of the most important forces driving this change is machine learning. You may have heard of it. It's changing how we live, work, and interact with the world. But what exactly is machine learning? Simply put, it's the ability of computers to learn without being explicitly programmed. In the past, we had to write detailed instructions for computers to follow. Now, with machine learning, we can feed computers data and let them figure out the rules themselves. This is a fundamental shift. It's like teaching a computer to think for itself. This has opened up a world of possibilities, from self-driving cars to personalized medicine. Machine learning is already all around us. It's powering our search engines, recommending products, and even helping doctors diagnose diseases. In this essay, we'll explore the fascinating world of machine learning. We'll learn how it works, its different types, and its real-world applications. We'll also examine some of its challenges. Join me on this journey as we unlock the secrets of intelligent machines. Imagine teaching your dog a new trick. It's a process that requires patience, repetition, and a lot of positive reinforcement. You wouldn't write down a set of complex instructions and expect your dog to understand them. Dogs don't read manuals or follow written guidelines. Instead, you'd show your dog what to do, reward them for getting it right, and gently correct them when they get it wrong. This hands-on approach helps them understand what you want. Over time, your dog would learn to associate your commands with the desired actions. They start to understand that sitting when you say sit leads to a treat or praise. Machine learning is remarkably similar to this process of teaching a dog new tricks. It's all about learning from experience and making adjustments based on feedback. We don't program machines with specific rules for every possible situation. Instead, we create algorithms that allow them to learn from data. Instead of giving them explicit instructions, we feed them massive amounts of data and let them learn from it. This data acts as the experience from which the machine learns. This data could be anything: images, text, numbers, you name it. The more diverse the data, the better the machine can learn. The machine then uses algorithms, which are like recipes, to find patterns and make predictions. These algorithms are designed to identify relationships within the data. Think of it like this: you give a machine learning algorithm thousands of pictures of cats and dogs. The algorithm doesn't know what a cat or dog is at first. The algorithm analyzes these pictures, identifying features that distinguish cats from dogs. It looks at things like fur patterns, ear shapes, and other characteristics. Eventually, it learns to recognize the patterns that define each animal. It starts to understand what makes a cat and a dog a dog. Then, when you show it a new picture of a cat or dog, it can accurately classify it. The machine has learned from the data and can now make informed decisions. This ability to learn from data is what makes machine learning so powerful. It allows machines to adapt to new situations and improve their performance over time. It allows machines to adapt to new situations, improve their performance over time, and even solve problems that we humans find difficult or impossible. This adaptability is key to the future of technology. For example, smart home devices learn your preferences and adjust settings automatically. They can learn your schedule and optimize energy usage, making your home more efficient. Autonomous cars use machine learning to navigate streets, avoid obstacles, and make real-time decisions. They learn from millions of miles of driving data to improve safety and efficiency. In healthcare, AI systems analyze patient data to provide diagnostic recommendations. They learn from vast amounts of medical records to identify patterns that might be missed by human doctors. In finance, machine learning algorithms predict market trends and help investors make better decisions. They analyze historical data to forecast future movements. Voice assistants like Siri and Alexa learn from your voice commands to provide more accurate responses. They adapt to your speech patterns and preferences over time. The applications of machine learning are vast and varied, touching almost every aspect of our lives. From entertainment to security, education to transportation, machine learning is transforming the way we live and work. As we continue to develop and refine these technologies, the potential for machine learning to solve complex problems and create new opportunities is limitless. The future is bright with the promise of intelligent machines that can learn and adapt just like we do. If data is the ingredient of machine learning, then algorithms are the recipes. Just as a chef needs quality ingredients to create a delicious dish, data scientists need high-quality data to build effective machine learning models. An algorithm is a set of instructions that a computer follows to solve a problem. These instructions are meticulously crafted to ensure that the computer can process the data efficiently and accurately. In machine learning, algorithms are used to analyze data, identify patterns, and make predictions. This process involves feeding the data into the algorithm, which then learns from the data and improves its performance over time. Think of a recipe for baking a cake. The recipe provides a step-by-step guide on what ingredients to use, how much of each ingredient to add, and in what order. Similarly, a machine learning algorithm provides a set of instructions for processing data. Just as a recipe might include steps like mixing, baking, and cooling, a machine learning algorithm includes steps like data pre-processing, training, and validation. Each step is crucial for the final outcome. These instructions tell the computer how to extract features, identify patterns, and make decisions based on the data it receives. Feature extraction is like identifying the key ingredients in a recipe, while pattern recognition is akin to understanding how these ingredients interact. There are many different types of machine learning algorithms, each suited for different types of problems. Some common examples include linear regression, used to predict a continuous value, like the price of a house. This algorithm finds the best fit line through the data points, allowing it to make predictions about new data. Logistic regression, used to classify data into categories, like whether an email is spam or not. It works by estimating the probability that a given input belongs to a certain category. Decision trees, used to make decisions based on a series of rules like approving a loan application. Each node in the tree represents a decision point, leading to different outcomes. Neural networks, inspired by the human brain, used for complex tasks like image recognition and natural language processing. These algorithms consist of layers of interconnected nodes or neurons that process information in a hierarchical manner. Just like a chef chooses the right recipe based on the dish they want to make, data scientists choose the right algorithm based on the problem they want to solve. The choice of algorithm can significantly impact the performance and accuracy of the model. The choice of algorithm depends on factors like the type of data, the desired outcome, and the available computational resources. For instance, some algorithms require more computational power and memory, while others are more efficient but may not be as accurate. Data scientists often experiment with multiple algorithms to find the best one for their specific problem. This process involves testing different models, tuning their parameters, and evaluating their performance using various metrics. Just as a chef tastes their dish to ensure it's perfect, data scientists evaluate their models to ensure they meet the desired criteria. This evaluation helps them refine the model and improve its accuracy. Collaboration is key in both cooking and machine learning. Chefs often work together to create a meal, and data scientists collaborate to develop and refine algorithms. Sharing knowledge and insights can lead to better results and more innovative solutions. Finally, just as a chef plates their dish for presentation, data scientists deploy their machine learning models for real-world use. This deployment allows the model to make predictions and decisions based on new data, providing valuable insights and solutions. In conclusion, the world of machine learning is much like the culinary arts. Both require a blend of creativity, precision, and experimentation. By understanding the recipes of machine learning, we can unlock the full potential of data and create innovative solutions to complex problems. Now that we understand the ingredients, data, and the recipes algorithms, let's see how they come together in the machine learning process. This process is like cooking a complex dish where each step is crucial to the final outcome. This process can be broken down into 3 main steps: training, testing, and prediction. Each of these steps plays a vital role in ensuring that our machine learning model is accurate and reliable. Training is where the machine learning magic happens. It's the phase where the model learns from the data we provide. We feed the algorithm a massive amount of labeled data. This data acts as the foundation upon which the model will build its understanding. This means the data is tagged with the correct answers. These labels are crucial as they guide the algorithm in learning the correct patterns. For example, if we're teaching a machine to recognize cats and dogs, we'd label each image as either cat or dog. This labeling process helps the algorithm distinguish between the two. The algorithm then analyzes this data, looking for patterns and relationships. It tries to understand the features that differentiate a cat from a dog. It uses this information to build a model, which is like a set of rules that it can use to make predictions. These rules are derived from the patterns it has identified in the training data. Once the model is trained, we need to see how well it performs on unseen data. This is where the testing phase comes into play. We do this by feeding it a separate set of labeled data that it hasn't seen before. This helps us understand how well the model can generalize its learning to new data. We compare the model's predictions to the actual answers and measure its accuracy. This comparison is essential to evaluate the model's performance. This helps us evaluate how well the model generalizes to new data. Now the fun begins. With a trained and tested model, we can move on to the prediction phase. We can use our trained and tested model to make predictions on new, unlabeled data. This is where the model's true utility is realized. For example, we can feed it a new image and ask it to predict whether it's a cat or a dog. The model will analyze the image based on the rules it learned during training. The model will use the rules it learned during training to make its predictions. This ability to apply learned knowledge to new data is what makes machine learning so powerful. This train, test, predict cycle is fundamental to machine learning. It ensures that the model is not only accurate, but also reliable and robust. It allows us to build, evaluate, and refine models that can make accurate predictions on real-world data. This iterative process of training, testing, and predicting helps in continuously improving the model's performance. Collaboration among data scientists and engineers is crucial during this process. Sharing insights and refining algorithms collectively can lead to more robust models. Machine learning models are now being deployed in various industries, from healthcare to finance, to make data-driven decisions. The ability to predict outcomes accurately can lead to significant advancements and efficiencies. As we continue to refine these models, the potential applications of machine learning are virtually limitless. From personalized recommendations to autonomous vehicles, the future is bright with possibilities. The journey of training, testing, and predicting is just the beginning. As we push the boundaries of what's possible with machine learning, we are paving the way for a smarter, more efficient world. And that's the essence of the train, test, predict cycle in machine learning. It's a continuous journey of learning, evaluating, and improving, driving us towards a future where machines can make intelligent decisions with remarkable accuracy.